Good afternoon, students. Welcome to the online session on design and analysis of algorithms. So today, in this session, we will be discussing Kruskal'S algorithm. So Kruskal'S algorithm has Prim's algorithm, Kruskal'S algorithm also. Okay, Kruskal'S algorithm also. Yes, a famous greedy algorithm. It's a famous greedy algorithm. It is used to find the minimum spanning tree of a given graph. Then again here to apply Prim's algorithm or Kruskal'S algorithm. Okay, as the purpose and agenda of both the algorithms are same, we can extend the usage or the discussion of Prim's algorithm for the Kruskal'S algorithm also in the same way. So Prim's or Kruskal'S algorithm is a famous greedy algorithms. Both are under the greedy technique. It is used for finding minimum spanning tree of a given graph. To apply the Prim's algorithm or the Kruskal'S algorithm, the given graph must be weighted, connected, and undirected. So these are the prerequisites, preliminary requirements that we need for a given graph in order to come up with minimum spanning tree. Okay. Then, so we have already discussed what do you mean by spanning tree, what do you mean by minimum spanning tree, and what are the requisites of the spanning tree, how many edges must be there in the spanning tree, like that. So all the basic discussions related to the spanning tree have already been covered in the previous session. So now we shall just directly step to the stepwise logic of coming up with a spanning tree by applying the concept of Kruskal's algorithm. In step 1, what we do, we sort all the edges from lower weight to high weight. So as we know, each and every edge in the given undirected graph will be having its own cost. It's also called as its weight of the edges. So in this approach, Kruskal's algorithm, what we do, we first sort all the edges from lower weight to higher weight. Edges will be sorted. Next, step 2, take the edge with the lowest weight and use it to connect to the vertices of the graph. First consider the one edge with the lowest weight, then connect it to the remaining vertex of the graph. If adding an edge creates a cycle, because we have discussed in the previous session, that is a the spanning tree is a graph without any cycles, without any loops, right? So if adding an edge creates a cycle, then reject that edge and go for next edge with the next least weight edge. Okay, fine. Then you must have to repeat these steps. What is step 3? Keep on adding edges, means you must have to repeat the step 2 until all the vertices are connected and a minimum spanning tree is obtained, MST in short. So this is the simplified stepwise approach for Kruskal's algorithm. So before again going to the Kruskal's algorithm, we shall just have a brief and fast look over the Prim's algorithm, which we had discussed yesterday's or a previous session. Okay, this is the working of Prim's algorithm. I hope you all remember. Okay, so this is the given undirected graph. We are applying the concept of Prim's algorithm here. We will be starting with the vertex, any vertex, or if it is not given, you can start with the vertex and the edge of least weight. So in the entire given graph, 10 is the least weight edge, and hence I will be starting with 6 to 1. Then I must have to consider all the edges reachable from 1 and reachable from 6. Reachable from 1 is 1 to 2, 28. Reachable from 6 is 6 to 5, 25, with weight is 25. Yes, 6 to 2, sorry, 1 to 2, 6 to 5. So these both edges are now in competition. These are in options now. So among these two choices, which one to select? The edge with minimum weight. So 6 to 5, 25 is the option that we have to select and proceed further for the next step. So this is how we must have to proceed. Next, we are having the options 1, 6, 5. Now we have to consider the edges that connects 1, 6, 5. All the three vertices now we must have to consider. So 1 to 2, 28 is there. 5 to 4, 22 is there. 5 to 7, 24 is there. Among these, which is the minimum? 28, 24, 22. So 22 is minimum. So I'll be selecting this and I'll go on proceeding like this, edge by edge, and I must have to see to it that the edge selected, among the edge selected, one vertex must be already in the selected set, another vertex must be new vertex. Both the vertex must not be already present in the selected vertex. One vertex is selected, one is new. One is selected, one is new. One is already selected, one is new. Like that, in each and every step, we'll be going on adding new vertex to the present graph. So this was the approach that we had followed in Prim's algorithm, and finally we had came up with minimum spanning tree. Now we shall step into Kruskal'S algorithm for the same graph. So what was the step one according to the discussion? The step one was we have to arrange or sort all the edges according to their weights. So if we sort all the edges according to their weights, we can clearly identify. So first, anyway, we have to come up with the minimum spanning tree. We have to write all the nodes like this. We have to write all the nodes like this. Then we have to go on adding the edges. So which edge to add first? First, we have to add the edge with minimum cost. So by seeing the entire graph, which is the edge with minimum cost? Minimum weight 10. Yes, so our next step is we have to add this edge 10. Next, as we have already sorted all the edges, which is the next edge with the next minimum cost? After 10, it is 12. Then add that here. We are adding edge 12. What next? After 12, it is 14. Next highest 14. Yes. And while adding the edge, what we must have to consider, what we must have to look into, adding a new edge must not create the cycle. Okay, next we shall proceed further. After 14, what next? Which is the next highest? I think it is 16. Yes, 16 is added. It is the next step. After 16, what next? Among the graph, it is 18. So there is edge 14, 16, 12. If I add the edge from 4 to 7, of course it is the next least weight edge, correct? But if I add this, it will lead to creation of or a formation of a cycle. So I must have to reject that, and I have to go to select next minimum cost edge, which is the next. So I will not be considering 18 because it creates the loop. So which is the next? Which is next? So this is 22. 22 will be selected. After 22, which is next? 24. So again, if I add 24 here, it will be leading to the formation of loop. So I'll not be considering 24, which is next. So 25. If I add 25, there will not be any circuits, and by this edge, we'll be touching, we'll be covering, we'll be visiting all the vertices in the given graph 1, 2, 3, 4, 5, 6, 7. And this is the minimum cost spanning tree by applying the concept of Kruskal's algorithm, and it's as simple as it is. See, this is the given graph. By applying Kruskal's algorithm, we'll be coming up with this minimum cost spanning tree. And since all the vertices have been completed or connected in the minimum spanning tree, so we should stop here. Now, what is the total cost or weight of minimum spanning tree? It's just the sum of all the edge weights. That is 10 plus 25, 22, 12, 16 plus 14, that it leads to 99 units. This is the minimum cost, the weight of minimum cost spanning tree. So you have to show how you arrive to minimum cost spanning tree like this stepwise. Each and every step you must have to show while writing the concept in the examination. And after coming up for the conclusion of minimum cost spanning tree, you have to write what is the total minimum cost obtained from the minimum cost spanning tree. Fine. Next, this is the example given in your prescribed textbook as per the VTU syllabus. We shall just have a brief discussion on how to understand this. So this is the given example, the same graph that we had taken for the prims. Okay, we were on this particular topic. This is the example considered in your textbook. We shall just have a discussion to understand this. So this is having the same graph that we had considered for Prim's algorithm, but the approach is for Kruskal's now we are discussing. So in Kruskal's approach, what we must have to do, we have to sort all the edges according to their given weight in ascending order. Now go on adding the edge one by one to the graph. Okay, first least weight edge is B2C with cost 1. I will be adding that. Next, as it is sorted already, without any disturbances, without any next thought, I can automatically move on to the next choices, the next entries. Okay, next is EF with cost 2. Yes, I will be adding, but only one thing we must have to consider is before adding, we must have to check whether it creates a loop or not. If does not, if it remains acyclic, then I can proceed without any disturbance. Okay, next is AB. Yes, I will be adding AB of cost 3. Next is BF, B to F. Yes, with cost 4 I am adding because it does not create any loop. Next is C to F. See here, C to F. If I add C to F, of course it is having the minimum cost compared to remaining edges ahead. But if I add C to F edge, it will be creating a loop. The loop will be formed. Hence, I will be rejecting this. Okay, what after C to F? It is A to F. Where is A to F? A to F again. If I add A to F, even though it is having minimum cost, it will be leading to the creation of a circuit, a loop. Hence, neglect or reject the edge A to F. Next, consider the next edge DF. Where is the edge DF? Yes, it is D to F. If I add this, it will not create any circuit, and hence I will keep this. After adding this edge, I'll be covering up all the vertices now. No vertices is remained uncovered. We have covered all the vertex, and hence stop. So this is the simple example depicted in your textbook. So you have to better if you follow this procedure of demonstrating the minimum cost spanning tree generation for any given graph. This is tree edge that is considered first edge, second edge, third edge, fourth edge, fifth edge. This is the sorted list of edges. So which among these available edges, which edge you are considering or selecting, you can just circle or highlight like this. Fine then. This is one more example. Just take a couple of minutes of time and analyze. Start with minimum weight edge. Cost is 1. Next, arrow mark is shown, which is the next step. The edge of weight 2 will be added. Next, the edge 3 will be added. Next, the edge with weight 5 will be added. Next example. I think it is easier to understand. Just have a look at this example. 10 minimum cost. Next, among this, yes, 20. Next is 30. Next is 40. If I add 40, the graph will be covering all the vertices given, and hence stop. So just go on adding the edges with minimum weight. So this is a very simple approach to come up with the spanning tree. So what the algorithm says as per the textbook. So Kruskal's algorithm for constructing minimum spanning tree. What is the input? A weighted connected graph G will be the input. Graph G is set of vertices and edges. Then what is the output? So it provides a set of edges. The set of edges will be the output. That set of edges will can compose a minimum spanning tree of the original given graph G. So the approach, sort E. What is E? Is the set of all the edges. What is ET? ET is the set of selected edges. ET is the set of selected edges in the spanning tree. What is E? E is the set of all the edges present in the given graph. So, yeah, sort all the edges in non-decreasing order, nothing but ascending order of weights. I 1 to number of edges. 1 to number of edges. Okay, then starting, no edge will be selected, and hence the set ET is null. and E counter, edge counter will be 0. Initialize the set of tree edges and its size. Okay, next k equals 0. Just have a variable. Okay, while number of edges selected, edge counter is less than number of vertices minus 1. As we have discussed already, the number of edges in the spanning tree is less than, one less than, exactly one less than the number of total vertices. So number of vertices minus 1, till it is less than that we must have to continue, we must have to go on repeating, and finally we'll be having some edges in the selected edge set and we must have to return that. Then as the algorithm proceeds, if et, what is et? Initially it is null, so go on adding the edge when I equals 1 to I less than end. Okay, to I less than end, all the edges, go on adding the edge one by one. If adding that edge retains the graph acyclic, if you union means nothing but addition operation, if you add that edge or if you consider that edge in the selected set of edges, and if that addition of edge retains the graph as acyclic, means if there is no creation of any cycle, then you can add that edge and to union. That union means you add that edge to the set of selected edges. First you have to check if it retains it as acyclic, then add it to the set of selected edge. This is just adding, this is just adding and checking. Here I am not adding it to the final set of selected edges. Here I am just assuming that if it is added, if it is added, the graph remains acyclic, means then you actually add and consider it as selected edge. Increment the edge counter, increment the k, and proceed with the same process till it is coming out of the while loop. Nothing but if all the vertices are covered, we must have to stop the procedure. Simple then. So I think we have discussed the approach of Kruskal's algorithm with sufficient number of examples, approach explained in the given textbook as per the syllabus. Okay, with referring some other examples in the internet as well. Okay, so I hope you have clear with the concepts. The session went on very well. Thanks for your participation.